I'm just going to go over units and variables. This is one of the first lessons that I like to show, only because it kind of lays the foundation for a lot of very important things that I talk about. And also, when I talk about these things, I usually just do it as if you already know what I'm talking about, and sometimes you don't. So this is a good one to revisit, especially when you find that I'm talking gibberish about certain things and you don't understand what's going on in terms of units and variables. So I will try to make this quick, just to make it efficient. So here we go. Values and quantities. There's a lot of vocab words in these slides. A value is a combination of numbers and their units. So when we say 6 or 4 or negative 99, those are values. It's an amount of something. Speaking of amount, the magnitude of something means the amount of, or how much. So if we're saying what is the magnitude of your height, we would say that 6 foot. That's the magnitude. It's just how much. So if you ever hear the word magnitude used in physics class, they're just talking about how much. Now, the reason why we use that word in magnitude in physics class is because sometimes quantities also have direction. So for example, if you're walking 5 miles east, that would be what's called a vector. If we want to know what is the magnitude of the length of your walk, then we would just say 5 miles, and we would drop the east because we don't care about the direction. So magnitude is usually used when we want to just get how much and we don't care about the direction or the negative sign or the positive sign. You can see there it says the balance value of the bank account is negative $200. So the magnitude of your debt is $200. We don't say the magnitude of your debt is negative $200 because magnitudes is just how much. Physical quantities are properties of an object that can be measured or calculated. So you have mass, length, time, volume, force, charge, etc. They might not be properties of an object, like time is not a property of an object, but these are things that we can measure and quantify and label with units and variable names and letters and all that stuff. So these are the things really that we focus on a lot in physics, is measuring, calculating, and reporting different masses, lengths, times, volumes, forces, charges, pressures, all these things. So that's really what physics is. So you kind of have to know what those things are. Variables. Variables are containers for values of physical quantities. So variables, normally we use X and Y in math class, right? That's something that you might be very familiar with. But in physics, we have lots of different physical quantities like mass, time, length, and we can't use X for all of them because that would get very confusing very quickly. So instead we use things like M for mass or T for time, and those are the variables that store the value of time. So if I say that it took 60 seconds for me to walk from one point to another, then T is the variable for time, which is the physical quantity, and the value, 60 seconds, is what we're storing in the variable T. So I know it's a lot of like, ugh, but when we practice with it, you'll see, or hopefully you'll just be at least aware. That's the whole point of this PowerPoint, is for you to look and understand when you're looking at these things, to try to make sense of them and just don't take them, as they come. So in this class, please refrain from using X and Y except for when you're supposed to, which are for X positions and Y positions. We don't use X for force or mass. We use F for force and M for mass. And that's just kind of how it goes, and it makes it a lot easier for us. Now this right here is a snippet from the AP Physics 1 equation sheet. And you can see that there's some equations and there's some letters, and they tell you what those letters mean. So equations are mathematical descriptions of how quantities are related to one another. That's what they are in physics class. Technically that's what they are, period, but I know that in math class you are used to just seeing an equation by itself without any context, right? You have a worksheet and it's just littered with equations and you just have to solve them. But in physics, that's not what we do. I mean, we do solve equations, but that's not why we do it, and that there's no context. Physics is all about the context of we are trying to figure out our physical world around us, and we have to use equations to figure those things out. So just as an example, look at the second equation there. It says P equals mv. P, if you look on the right, it says lowercase p is equal to momentum. So momentum is equal to lowercase m, which is mass, and lowercase v, which is speed. So momentum is equal to mass times speed. That would be how you would read that equation, and that makes sense to us, or maybe it doesn't make sense yet, but you can understand how there's a relationship. That's what equations show, a relationship between physical quantities. Momentum is equal to mass times speed. So it's related to mass and speed. On the AP equation sheet, they give you all the equations, and they also give you all of the letters so that you know what those letters stand for, the variables, and so you don't have to memorize it. You can use that whenever you want. You are responsible, though, for navigating the equation sheet, which means you are responsible for taking the equation sheet out and looking at it and knowing where things are and knowing how to look things up. So that's what I want you to focus on. This is not a problem that we're going to solve today, although I'm sure you could figure it out because you're very bright, but this is just what it might look like. And I just want you to, instead of trying to read it and understand it, just, take a step back and just look at it. You can just see there's letters, there's numbers, there's letters on one side, on the other side, there's lots of M's, there's zeros everywhere. It's just, there's equality signs, like there's a lot of things going on, and I want you to know that you are going to be responsible for being able to look at these without any context and at least have some understanding of what it means. This is how we're going to be solving problems, and I just want you to understand that we will be using these letters frequently, so you're not going to be able to get away with just doing x equals 2 plus whatever. We have to use t and v and d and all that. Units. Now, as you saw in that previous example, there were more letters that were not variables. So this is something that gets confusing for some of my students, is that there are letters for variables and then there's letters for units. And the units always go at the end of the measurement or the calculation. That's how you know they're units. So if we look back at this one, you see v equals 20 meters per second, or m over s. That m over s is the unit and the v is the variable. So 20 meters per second is stored in the v variable. Units are how we describe measurements or calculations. They always go on the end. And in this class, we do not need to use them in our equation as we solve, but we always need to use the final answer with units. So what I mean by that second bullet is that if we're solving a problem, if you look at the green, where it says 400 divided by 20, you don't have to put 400 meters divided by 20 meters per second. Although you could, and it would still work, you would be able to see what the units are better. You don't have to do that in my class. Each quantity has its own units, and you'll learn these throughout the year. I expect that when I tell you a unit, that you know it. After I tell it to you and after you practice with it, you should know it for the rest of the school year. So that's something that you're going to have to practice, memorize, or whatever you need to do. If you look at the top, though, that is a snippet from the AP equation sheet, and it tells you what some of those symbols stand for and the names of those units. All right, symbols. So if you look at this other picture, this is another snippet of the AP equation sheet, and this has some of the scariest looking equations that I could get all in one picture at the one time. The only reason why they're scary is because there's just lots of symbols and letters and numbers going on. At some point in the year, this is going to look familiar to you and you'll be able to understand it. Right now, it might be really scary, but that's okay. We're going to understand what all these symbols mean over time, but I want you, again, now to look at this and be like, okay, this is what I'm getting into. Some of those symbols include Greek letters. There's a scary looking, if you look at this sigma, it looks like a capital E maybe. There's lines and arrows above some things. You see these little arrows above the F and the A. There's math operators, so you see the absolute value symbols and this inequality here, exponents, subscripts, over here. It's just as important to understand what these mean as it is to understand what those letters, the variables, mean. So The English alphabet only has 52 letters if you include upper and lowercase, and there are thousands of physical quantities for us to label. By the way, I didn't mention this yet, but we use upper and lowercase separately, so it is important that when you're doing physics problems, you are using the correct case when you're writing it down. So make sure a capital M stays a capital M, a lowercase m stays a lowercase m. But we ran out of letters, so we dipped into the Greek alphabet to help us. One of those is, if you skip down, it says delta. It's basically a triangle, and if you look at the picture there, it's a tattoo of a delta, but the delta is not quite closed, and I think the intention there is that, delta means change, and this person said that the delta is unfinished, so the change is not done yet. So this person is changing, and they're still not done changing. So these symbols sometimes mean things other than just replacing for a variable, like delta means change in. You can put delta in front of almost any quantity. Delta T is change in time. Delta M is change in mass. Delta F is change in force. So we can use delta in lots of different ways. And sigma, this giant thing here, means take the sum of. So this sigma is saying take the sum of all the forces. So whatever you put that sigma in front of, it's saying take the sum of all of those things. One Greek letter, mu, can be seen as a metric prefix, and we're going to talk about metric units in a different time. But we can use metric prefixes as well that have letters that go on the end or in the front of units. Those lines and arrows above the variable, those arrows mean that it is a vector. So a vector, we're going to learn about that later, but basically it's just, it has direction. That's all that means. We'll talk about that later though. The perpendicular symbol just means that those things are, we're only talking about the perpendicular part of it, or the parallels, parallel, and then absolute value, of course, means the absolute value. And then we have subscripts. A subscript is a letter or text that is below the text, subscript. There are common subscripts that we see in physics. If you see a 0, that means naught. That means it's the initial, the starting value. But we also use I and F for initial and final. I can be initial. We can start, like let's say we start a car, we push it down a hill. At the top of the hill, that will be naught. And then as it's rolling down, we can pick two spots as it's rolling down the hill, and we can call one initial and one final. And that's basically what you do. And you can add those onto any quantity there. So T initial would be the initial time, and T final would be the final time. If you see an X or a Y subscript, that just means that it's the X component or the Y component, meaning that it's either going in the X direction or it's going in the Y direction. We're going to talk about that more. All these things we're going to talk about more when we get to them, but I want to give you just a general overview now. And you might see other letters. You can treat those as just like labels for forces or energies. And finally, we have constants. Constants are values that are constant. They stay the same, and these are usually given to you. In fact, this again is a snippet from the AP Physics 1 equation sheet, and you can see that they're given to you. They give you the units, they give you the variables for them, or the letters that they stand for, and they give it to you, so you don't have to memorize it. And I'll skip that last thing. We don't have to really talk about that yet. So that's it for that. Please understand that you're responsible for knowing what letters mean, and if you're ever on a test and you're like, what does F mean, what does M mean, you're struggling and you need to reach out for help, all right? But hopefully this kind of gives you a nice overview of what physical quantities and units are going to be in AP Physics 1.